C. The Harry Potter box is C.
Excellent.
It's C. You need it.
Okay, so yesterday I said we're going to learn to find the square root of complex numbers. Okay. Which might sound bizarre, but it's actually not that bizarre.
I think you're running away with this before you get.
You want to get?
I don't do it after maths. I know.
Yeah, after that. Okay, so we want to find the square roots of complex numbers, right? So I've underlined the VS there for a particular reason. Okay, square root. Why am I saying square root? If you think back to square roots, when you learnt about square roots, the first time that you met square roots, right? Let's take the square root of 25 for instance. What's the answer for the square root of 25? What is the square root of 25? Okay. When you first learned maths, you learned about just the number 5. Why did we not tell you about the other solution when you learned about square roots? Think back to when was the first time you think you ever encountered square roots?
I actually can't remember anymore.
Grade
At
9.
some point.
When do you think is the first time that you ever thought you met a square root? If you have considered that.
Grade 9.
In grade 1, when
think
we
back
were
to grade
learning our
4,
times table.
5. There was a guy that you had to use in order to calculate the hypotenuse of a right angle
I
triangle.
wasn't calculating the hypotenuse of a right angle
I was
triangle.
old school.
Grade 4.
I learned that
I was in
like grade
Dolphin.
9.
No, Mr. James, I was in Dolphin school, so I was learning 7 times 7.
Oh goodness. Anyways, why when you learned Pythagoras did we not teach you about the negative solutions?
Because then it was
Negative.
Because length cannot be negative, right? So we just forgot to mention that there's actually another solution. Because we know that minus 5 is also a valid answer. Alright?
Yeah.
What does the square root of a number actually mean? What are you asking yourself? What are you asking yourself when you're saying, give me the square root of 25?
Equal and opposite factors of the number.
Almost. What are you asking yourself? You're asking yourself, what number can I multiply by itself and I'll get the result? Okay, so we know we can multiply 5 by 5 or minus 5 by minus 5 and we'll get 25. Right? So when we look at the square roots of complex numbers, do you think they're any different? How many solutions do you think we'll get when we take the square root of a complex number? 1, 2. Well, there must be 2. And when we find these roots, what must we be able to show? If I take my answer and I multiply it by itself, I should return back to the thing under the square root. Okay? So let's consider some complex number z. Right, and let's make z equal to minus 2 minus 2 square root of 3 I. Now I think your textbook accidentally made this minus sign incorrect. It's supposed to be a plus because that would be the standard one. This is a standard one that most people learn when they're learning about square roots. And then they just carried on with their mathematics in the textbook, forgetting that the solutions were actually incorrect. Okay. So,
Oh, did you manage to solve that other one? Because the more I tried, I can't figure it out.
it's not possible.
It's
The thing they gave you is wrong.
Okay.
Okay? So, let's say z is some complex number, and it is equal to the square root of minus 2.
So it's not just being dumb.
No, it's not. I got it to a point where I got exactly like you, 1 minus 1 over r, which you can factor out, but you can't do anything with it. So how they got their solution is impossible. And I went and looked in the working solutions guide, and it just gets to a point and it stops.
Wow.
So
they
clearly,
trolled us.
so somebody, even the guy that was doing the work solutions, like, well, the textbook's probably doing it, so I can't do anything now.
Or maybe they wanted to do like that thing where you just suddenly change a number by accident so that it all cancels out and looks pretty in the end.
Okay, so what we want to do is we want to find 2 solutions here. Okay, we want to find the square roots of this complex number. Here's the real part, here's the imaginary part. And we also want to draw this on the Argan diagram, because if you can see the two complex numbers when they are the square roots, it's going to help you if you need to find other square roots. So what do you think is the easiest thing that I should do? What's the generic way that we normally write complex numbers? I'm looking for a complex number, it's z, right? It's the square root of this number. So what is my complex number? What must it have? What do all complex numbers have? What's the most basic way to write a complex number that you don't know yet?
X plus y.
There's my complex number. I don't know what it is yet, but I know, what do we know about complex numbers on both sides of the equal sign?
They're equal.
Their real parts must be equal and their complex parts must be equal. Okay? What's the big problem in this equation here? The square root, right?
We can pull out square root.
So why don't we just square both sides and get rid of it? So what I'm going to do is I'm going to square both sides and I'll be left with just this, minus 2 square root 3i. Okay? Because this might be easier to work with. Okay? I unfortunately need to expand out now. So let's just do that. That's quite a simple expansion. I'm going to get x squared. Then I'm going to get 2 of the middle terms, because this is a square. So plus 2xyi. And what's going to the last term be?
Minus.
It's going to be y squared, I squared. I squared is just minus 1. So we're going to get minus y squared. And that's going to be equal to my complex number. Okay? Equals minus 2 square root 3i. Now from here, we're going to collect the real parts and the imaginary parts separate. Okay? So the real parts are my x squared and my minus y squared. That's the real parts. Right? They don't have any imaginary component. This plus 2xyi, it's my imaginary part. Okay, so this plus 2xyi, there's my imaginary part, and this is all equal to the other side. So now we can just compare. Now we can just compare the real parts. Here's the real parts. And here are the imaginary parts. And we learned that if two complex numbers are equal, what can you tell me about their real and imaginary parts? They must also be equal. Okay? So let's make them equal. So I'm going to get x squared minus y squared equals to minus 2. There's an equation, equation number 1 we can call that. And I'm going to get 2xy equal to minus 2 square root 3. Okay. Now I have two simultaneous equations. Can I use elimination to solve this? No, because I've got x squared, so nothing's going to cancel out. So I need to use substitution. Okay, so I'm going to make one of these the subject of the formula. Which number would you like? Shall we make y the subject of the formula? We always like making y. So I'm going to divide both sides by 2x. What's going to happen to this minus 2 over here? It's going to become just minus 1. So we're going to get minus the square root of 3 all over x. And we can call this equation number 2. So let me put this inside equation number 1. So you can say substitute equation 2 into equation 1. The x squared stay unchanged, and then we have minus. We're going to replace y with this minus square root 3 over x, and that's going to be equal to minus 2. Right, what's going to happen on the inside here? When this is squared. Okay. What's going to happen to this thing on the inside? The minus and minus are going to cancel out. What's going to happen to the square root 3 when you square it? It's just going to become?
Minus 3.
No, remember the minus is also being squared.
Oh, okay, so it's going to become then just 3.
X squared, but then we've also got this minus out the front. So it will become minus 3 over x squared equal to minus 2. Now I have a x squared on the denominator. This is an equation I want to get rid of it, so I'll multiply the whole equation by x squared. So I'll get x to the power 4 minus 3 equal to minus 2x squared.
And then you move that to the side.
I'll just move it over, so I'll move it x to the 4 plus 2x squared minus 3 equals 0. Now that's interesting because what did we learn yesterday about polynomials of degree 4? How many solutions must you get? 4. But that's not possible because square roots have how many solutions?
2.
So we'll see where this is going to go.
Oh, I have a theory that it's going to be 4 roots, but 2 are going to be the same.
Okay.
Both 2 roots.
Let's have a look and see. Let's have a look and see.
Yeah, no, like I said yesterday, you have to take the square roots of those.
Okay. Nope, that's not it. So let's just solve this, because by solving this I will find my values for x and y, because that's the values of my complex number that I'm interested in. Okay? So we can use that k method, or we can just realize that this is just the middle term. So either way, you can either change this to y squared, whatever. I'm just going to do it like this. X squared, I need plus 3 x squared minus 1 equals to 0. That gives me my x to the power 4. There's my plus 3 minus 1, which gives me 2, gives me minus 3, so I'm good. Have a look here. What kind of solutions are you going to get here? This is the sum of, you're going to get x equal to,
3 bars.
if I take x squared equal to minus 3 and I take the square root, I'm going to get two complex solutions. This is going to be square root 3i plus or minus square root 3i. Yeah, and here I'm going to get, well, this is the difference of squares, so I'm going to get x equal to plus or minus 1. Now tell me, why are two of these solutions not going to work? I want you to look back at what we're trying to solve. What are we trying to find? We're trying to find x and y which belong in a complex number. What can you tell me about these numbers? What must they be?
They're not real.
They must be real. X and y are elements of the real numbers. Are these real numbers? No, they're complex numbers, and so we discard them. So the only two solutions we want are x equal to minus 1 or plus or minus 1.
And I got y equal to plus minus 3.
Okay, well now we've got the x, so we need the y. Yeah, so that's where you're going to get your two solutions. So when x is equal to 1, then y is equal to minus the square root of 3 over 1, so that's just minus the square root of 3. And the opposite will be x equal to minus 1, y will be equal to the square root of 3. Okay? But I haven't finished yet because now I must write my complex numbers. So z is a complex number in the form xiy, right? It's equal to the square root, and the square root has two solutions. So here are my two solutions, and so I can formalize this and say z is equal to 1 plus, minus square root 3i, or z is equal to minus 1 plus the square root of 3i. Those are my two solutions. Is that making sense so far?
Yeah.
Okay. How can I check if my answers are correct? Well, why did I check? If I take one of these answers, what should I be able to do? This is the square root, right? I got 5 as an answer. How can I check that 5 is actually the square root of 25? I can take 5 and multiply it by itself. And then I should get the thing under the radical. So let's take one of our solutions and quickly check. Do I get back to that? Because if I don't, then my solution's not right. And if you check your textbook, you will find that the solutions they got don't get you back here, because I think they forgot to make this a plus. Anyways, let's take this one here. We're going to take 1 minus the square root of 3i, and we're going to square it. So in other words, I'm going to take it and multiply it by itself. So let's just write that so you can see. 1 times 1 is going to give us 1. Then we're going to have 2 of the middle terms because they're the same. So what is it going to be? Minus square root of 3i and another minus square root of 3i. So how many of them will we have? Minus 2 square root of 3i.
And the other one is 3
This is going to cancel out to become 3 because the minuses are going to cancel out. But then the I squared is going to make it minus again. So we're going to get minus 3. 1 minus 3 is minus 2. Minus 2 square root of 3i. We can check. Oh yeah, we got back to where we belong. So is finding the square root of complex numbers actually difficult?
No.
Not at all. Okay, I'm going to show you an easier method as well, if we can use exponential form. Okay? Right, the last thing we want to do is we want to draw these two complex numbers on the Argan diagram. Okay? Because we want to visualize where they are. So the Argan diagram has what components? This is the real, and this is the imaginary. So let's think about where our complex numbers are. Where's the first complex number sitting? What's its real value?
Real value is 1.
1, and its imaginary value is?
Negative.
What is negative square root 3, roughly?
Like 1.
Check it for me quickly on your calculator so we can draw this somewhat accurately.
1.7.
1.7, so that's just before 2. So let's say around about there. So here is my first one. Z equal to 1 minus the square root of 3. Okay, where's the other one?
Minus 1.
Minus 1 and?
Well, positive square root 3.
Positive square root of 3i. So that's maybe somewhere over there, right?
Just continue the line.
So I can continue the line. Now, I know that I'm interested in the line. You can see that the line is straight. But what does that tell you?
You have two opposite roots.
Okay. What can you tell me about the angle that the two square roots make? Not 180 degrees? Because we don't work in degrees when we work on the complex plane. There is pi degrees difference between a square root, the two square roots of two complex numbers. Okay? Or we're multiplying it by I squared. So there you go, that's the square root of complex numbers. So if you want to find a complex number's square root, you can find one solution. And you could find its other solution just by determining where its position is in the complex plane. Okay, that is when we find it in Cartesian form. Okay, what other forms do we know that we could use? Would we want to use mod arg form to find square roots? No, but what's a nice condensed way of writing?
We tried that yesterday, it wasn't very fun.
What's a nice condensed way of mod arg form? Exponential form, okay? So let's take a look at this exact same question, but now let's have a look at it from the exponential form. How would we calculate this using exponential form, okay? So we can write our roots up here just so that we can check and get the right answer. So if I want to use exponential form, what's the first thing that I need to do? Well, I need to change this thing into mod arg form. And even though it's under the square root, we can't use it right now because it's of no use to us. Okay, so let's change this into mod arg form. How do we change to mod arg? We need to take the modulus of this complex number. So let's take the modulus of minus 2 minus 2 square root 3 I. What's its modulus?
Don't you need to do the square root first?
No, we're not worrying. We need to first change this into mod arg. Not mod arg, into exponential form. This number is not even in exponential form yet, so we don't even care about taking the square root of it yet. So let's change it into exponential form. I need to find the r. I need to find r, which is the modulus of this number. That's just going to be the square root of 2 squared plus negative 2 root 3 squared. That's going to be 4. That's going to be
212.
We have 16, so this is just going to give us 4.
Minus.
No, never be minus.
Ah, the big plus.
What did I put
The
here?
big plus there first.
No. It implies that when I don't put anything in front of the square root, I want the positive solution. If I wanted both, I would write plus minus. This implies the positive, because we don't write the plus. In fact, when you write the number 1, what should you write in front of it?
Plus 1.
You should write plus 1 to imply, but it's implied. Okay? Okay, now we need to find the argument of this complex number. So we need to find the argument of minus 2 square root of 3 pi. What's its argument? How do we find the argument again?
Minus.
We draw a picture.
Oh yeah, true.
We think about where is this complex number sitting? It's minus 2 minus somewhere. So it's here in this quadrant. So the angle I'm looking for is here. Okay? There's the angle that I'm interested in. So I can use that fancy trick where this is minus 2 and this is minus 2 square root of 3. We can find this angle and then we can take it away from.
Pi. So minus.
It works out to quite a nice angle, doesn't it?
So pi minus is -2 over negative pi on 2.
Negative 2 over 3 pi.
Yeah, so minus 2 over 3 pi. Oh, isn't that nice? It just works out so nice, doesn't it? I wonder why this example is always commonly used. Because it gives out nice numbers. Okay? So if I want to change this back into exponential form, I'm now looking to find z, the square root, but it's now in mod arg. We're going to change it to exponential. So we put the modulus, and then it's e to the minus 2 over 3 pi I. There we have in. Okay, now remember we changed z into its complex number x plus iy. What is a complex number, a generic complex number in exponential form? Right? If z in Cartesian form is this, what is it in generic form? R e to the I theta, because we haven't filled in any of the blanks yet. Okay, so I'm going to change my z into r e to the I theta. And I'm going to do exactly the same thing I did before. How do I get rid of that pesky square root now?
Square root of
When you square an exponential, what do? When you raise a power by a power, you can just multiply. Right? So I'm going to get r squared on this side. And then when I take e and I square it, I just multiply the power by 2. So I'm going to get e to the I 2 theta. And here we will just get 4 e to the minus 2 over 3 pi I. Okay. These are equations, right?
Mm-hmm.
So what must their different components be then?
Equal.
So r squared must be equal to?
4.
And 2 theta must be equal to?
2 theta must be equal to minus 2 over 3 pi.
Okay.
So theta is equal to minus 1 over 3 pi.
Okay, so theta is equal to minus 1 over 3 pi. And what's r equal to?
Plus or
2.
minus 2.
Okay, now I'm going to write plus or minus 2, and then I want you to take a step back and think, what is r?
Magnitude, so that's the opposite.
So can r be negative? No. Now this is going to cause a problem, right? How many solutions do I need for complex root? I need, no,
2.
there's 2. Remember, 2 of them we discarded because they were not real values. Okay? So if I don't consider plus and minus, where am I going to get my other solution from? I can't make the modulus negative, so I can't take negative 2. So where's my other solution going to come from?
Maybe going on the other way?
Well, why don't we consider the first solution? Okay, let's just consider the first solution. What's the first solution? Let's stick it into the equation. R is equal to?
2.
2? Sorry, this one. Z is equal to 2. And then e to the?
Minus pi 3 pi on 3 I.
Okay, there's my first solution. So where is my second solution?
Can't we consider the negative of both of those? So negative 2 and positive 3 I.
And
Or is it just one?
Think back to when I showed you in Cartesian form.
Oh yeah, 180 degrees from it, which means that we're going to have a pi difference.
So, that showing you where they were was not just
We're
a
gonna get pi
fluke.
on 3.
Here is minus pi on 3. No. There. Somewhere there. So here's my complex number, somewhere over there. It has magnitude 2, and its angle with the real axis is minus pi on 2. Where is the other root? It must be exactly how many degrees away?
Pi degrees away.
It must be exactly pi degrees away. So what is exactly pi degrees away?
Pi on 3.
We just add a pi. So I'm going to get sure?
Yeah, pi on 3.
2 pi on 3.
We're at minus pi.
Yeah, we're at minus pi, and we need to go around that way.
So 0.
No, we're at minus pi. Here's our complex number that we found.
Oh, yeah.
E equal to pi minus, you see now, right? We're going that way around, okay? So when you have minus a third and you add 1, you get 2/3. Okay, so your other complex number is z equal to 2 e to the 2 pi on 3. And you can check on your calculator if you want. So at this point here, it would be tempting to, you could have, by the way, just slapped the minus 2 in front of here and called it quits. But would that be right? Is that in exponential form? No, because the magnitude of this number can never be negative. So we have to consider the angle and change this, right? You would get it wrong if you gave it as minus 2, right? You must remember that the angle of a complex number, the two squares are always pi degrees apart. Okay? So you can draw yourself a little diagram once you find the first solution and think about where the other number
It's
must be.
not that big mechanics, though, it's something in direction of motion, yeah?
Yes.
So one direction follows this or the other one.
Okay, so there's quite a couple of them for homework, so hopefully you can get the swing of things. It's important that you know how to do this method and the other method.
So you can,
Which method did you like more?
this one.
The other one I think.
So I guess it just depends how if you get the question in Cartesian form, then just do it in Cartesian form. Because look at all the work we have to do to get there. Right? But if the equation's in exponential form, well actually if it's in exponential form, it's so much easier to work it out.
Yeah.
Right? If it's already given to an exponential form.
Otherwise it's not nice.
Otherwise it's not nice because there's work to get there.
And we're lazy because we're mathematicians.
Yes, very nice. Okay, so that ends square
Well,
root.
I've shown you my ability to be lazy.
Kiana, you are the king. I mean,
I remember I asked him he asked me for the answer and I was like,
math is designed.
and then at the denominator it's like 2 times 3 times 4. Come on! I didn't buildings and stuff.
Okay, interesting. Let's have a look at the cube roots of 1. The cube roots of 1, the number 1. So, consider this equation here.
What did you write?
Unity. So, unity. We're going to use this as a unit, as a base. The answer we're going to use as a base. We'll get that. Right, let's think about this very easy question, which you've known your whole life. What's the cube root of 1?
Oh no.
It's 1, right? I mean, 1 times 1 times 1 gives you. So, you're saying that the cube root of 1 is 1. Okay? Now, what does the fundamental theorem of algebra that we learned yesterday say about a degree 3 polynomial?
That's
It must have 3 roots, right? So what are the 3 roots? Are they all just 1?
Yeah.
Okay? Let's say you think they are all just 1. If a number is a root, then what can we do to it?
2.
No. If 1 is a solution, then what's the factor?
1 plus 1.
No, what's the factor?
1. Minus 1, sorry.
X minus 1. So if you're saying 1 is the solution, and 1 is 3 solutions, then 1 is a factor. But if 1 is a factor for a solution 3 times, then that's what its equation must look like.
Then you're getting 0.
And if you expand this out, you're going to get x cubed minus 3x squared plus 3x minus 1.
Which is 0.
No, but that doesn't look like this equation.
Well, no, even if it was, it's just equal to 0. Another 1.
Yeah. But if you're saying 1 is a factor 3 times, then, or 1 is a solution 3 times, we're saying a degree 3 polynomial must have 3 solutions. And Dominic suggested that all of those solutions are 1.
Yeah, I know.
But if all of those solutions are 1, then x minus 3 must be a factor, or x minus 1 must be a factor 3 times. And if we expand that out, are these two equations comparable? So is 1 a factor 3 times? Well, 1 is a factor 3 times in this equation. It would be a solution 3 times. But what about this one? So what have you been falsely assuming your whole life?
So it's just 1.
Yes. So is it? So what are the other solutions?
Complex.
Okay, they must be complex. They've been hiding beneath the hood your whole life. So how can we find them?
Integration.
No.
By substitution.
Here we go. Let's change this equation into something we are familiar working with. And now let's just solve it. Okay, we agree that 1 is a factor, right? 1 is a factor. I mean, 1 is a valid solution. We can prove that by putting it into the equation. It satisfies it. That means that x minus 1 must be a factor. And if I divide a cubic by a linear function, what do I get out the other side? What must be in here? There must be a quadratic. So let's think about this quadratic. What must I multiply the x squared by and the x by to get x cubed?
X squared.
Just x squared, right? No coefficient. And the last number, right? I need minus 1. I have minus 1, so I should have a plus 1. And then there's a missing term in the middle here. This plus bx. Okay? So why did we consider this from the x squared term? What's the x squared term on this side? Well, I don't see one, so it must be 0. And now, what gives me x squared on this side? Those two terms and these two terms. So these two give me b, and this one gives me minus 1. So b must be equal to 1. So now we can rewrite our x cubed minus 1 as x minus 1, x squared plus 1, x plus 1. And I'll just take that one away for simplicity. And now,
We use formula?
we will use the formula here because I can't factorize that, and you should recognize this. We've done this quite a few times. Is this going to give real solutions? No, this is going to give complex solutions. So x plus or x minus 1 is one of our factors. Right? Therefore, x equal to 1 is one of our solutions. And x equal to, well, let's go minus b, so minus 1 plus minus the square root of b squared, which is 1 squared minus 4 times 1 times 1, all over 2 times 1. There's the formula. So we get the square root of
Minus half, plus or minus square root.
the square root of 3. So we have 1 minus 4 in the bracket under the root there. So we're going to get minus 1 over 2
Plus or minus.
plus or minus the square root of 3i over 2. So there are all the solutions to what is the square root of, or the cube root of 1. Okay? There were two complex solutions hiding under the hood the whole time.
It's actually pretty cool.
So you've been hoodwinked your whole life, right, into believing that 1 was a solution and the only solution, right? And how can we prove that these are solutions? We stick them back into the original equation, and what should come out?
Yeah, then it should
We should get 1. Okay, now this is quite an important thing to try and remember. You need to be able to get to this very quickly.
Was this what you were referring to? I forgot this movie existed. I love this movie.
Yeah, good way.
Good. in the city to find like the evil lair of Hansel and Gretel, and it ended up being this really foreboding castle. Was that the second one or the third one?
Probably not a two.
Probably the second one, yeah. And there was a
No, but you didn't do too well, eh?
That's sad. That was my favorite one.
11% rating.
Okay, I'm going to take off our solutions and we're going to do one more. Okay, the reason we call this
I like it.
unity, right, is we've now considered what is the cube root of 1. So that now begs the question, what about all the other cube roots that you've been lied about? So you know how I, the square root of minus 1, equal to I, that's like the unity, right? We break everything back into, right, so if you consider like the square root of minus 25, you're breaking it up into the square root of minus 1 and the square root of 25. Because you can work with the square root of 25, and then you just change the minus 1 into I. So we can do that with all the other square roots. So let's consider this. Solve this equation. You've been lied to your whole life. What did you consider as the only solution here?
This is that thing I told you about, remember?
What did you consider as the only solution here?
That's a lie.
Here's the formula.
Okay. No, well, we're not going to use that.
Why not?
To solve this.
Well, you don't need to, but it works.
Yeah.
Just told you exactly what to put.
Yes, but try to remember that, because you don't get that. You don't get given that. That's not given to you.
But it is pretty easy. It's pretty easy.
Okay. How can we use what we just solved with the
X cubed minus 2 cubed.
so we can have x cubed, or x is equal to the cube root of 8. What can I pull out of the cube root? I can pull out 2, so I'm going to get x equal to 2 times the cube root of 1, which we now know is there only one solution to the cube root of 1. No, we were lied to. Okay? Except I can see that my solutions are just going to be twice the cube root of 1. And so I can use the cube root of 1's solutions to help me solve this, instead of having to redo all the work. Okay? So what will my solutions be? So here are the solutions. I wrote them down there. So the first one is the most obvious one. It's the one that we all thought was the only one. X equal to 2 times, well, 1 was the only solution we thought about. Or x is equal to 2 times, we'll take one of these solutions, so minus 1 over 2 plus or minus the cube root of 2i, and I'll multiply the 2 in, and what will I be getting? Minus 1 plus or minus, so there are your 2. So those are the real and complex solutions to the cube root of 8. So you've
Just remember this one.
just been told the tooth fairy didn't exist.
Learn this one. This is actually
Oh, I thought you were going to select a long
I don't know if this is
form.
clear.
Okay.
Right. Paste back.
It's so easy.
Paste back.
I'll try.
Should I send it to you?
Yes, please. Send it to me and then I shall.
It's not that necessary to do, Dominic, because
You are having it.
you can work it out again.
I could.
Okay, 11D, we're still on 11D.
Yes. Are we? Are there any more questions?
Yeah, we're going to go back and do the questions that you didn't do because you hadn't learned about them yet. A, B, C, F, that's the question. It's just a couple of questions on calculating the square roots of complex numbers in their different forms. And then there's a couple of questions on using unity, so using the square root of the cube root of 1 to help solve the cube roots of other numbers that you were lied about your whole life.
We had a question yesterday.
Do you feel like going back and talking to your math teachers? They were lied. They were told there's only one solution.
I have a question for you. X cubed equals 1. What is x?
X.
What?
X is X. I don't know why you're trying to bother me.
I love how
X is X. What did you want me to say? It's X.
Did our
How do you quotes? Is that supposed to be root negative 1?